All right, let's talk about another alternative energy source most of us have heard or know a little bit something about: solar. So solar energy is energy captured from sunlight, sometimes with advanced technologies. Not always, sometimes. So there are things called active solar energy, and then there are things called passive solar energy. So technologies that employ active solar energy include photovoltaic systems. Fancy word. Photo, light. Voltaic, produce electricity. So using light to produce electricity. Solar panels, essentially. So photovoltaic systems, solar panels. Another active solar energy use includes solar water heating systems, as well as large-scale concentrating solar thermal systems, CST systems. We'll talk about each of those. When we look at the United States, this is a map that shows a variation in solar radiation potential. How much sunlight are we getting, essentially? The darker the brown color, the more energy that hits the part of the U.S., the more solar energy that hits the U.S. in that area. So no gas, it's very sunny here in the desert Southwest. So the potential to harness the most solar energy is in the Southwest. Whereas as you get into, the shades of blue, the less solar energy, because maybe it's cloudy there, it's further away from the equator, so you're getting less sunlight in general. A number of different factors. But the highest potential is in the Southwest. But it's kind of interesting, and you'll see this in lab, that's not where most solar panels are located. Boggles the mind. But the potential to harness solar energy is the best in the Southwest. But that's not where most solar energy is being harnessed. An example of one in the Southwest is the Agua Caliente solar photovoltaic facility. That's a mouthful. It produces 290 megawatts of power. So you can see how big this solar panel field is compared to kind of the road that's right here. It looks like they're also looking to expand. It covers 2,400 acres outside of Yuma. That's a lot. All right. It supports 230,000 homes. The energy that needed for all of those homes, 230,000 homes, that cuts 324,000 tons of CO2 annually out of the atmosphere versus if that electricity was generated by coal or natural gas. That's equivalent to taking 70,000 cars off the road. That's a lot. That's awesome. The drawback, something like this, almost cost $1 billion, $967 million. Big upfront cost. After that, maintenance, cleaning, relatively low. So again, these are photovoltaic solar panels. That's just the fancy name for them. Sometimes, again, there's big fields of them. Sometimes you have a few on your house. Photovoltaic solar panels. I won't get into too much how they work. It's a little complicated. But in essence, you have a solar panel. You have some different material in there. When sunlight hits it, sunlight is made up of photons, these bundles of particles of energy. It's little physics. Stick with me. When this little bundle of energy, this photon, hits the solar panel, it knocks loose an electron from one side of the panel to the other side of the panel. So you're moving an electron. The electron are the outermost part of an atom. You have the nucleus, protons and neutrons, and the electrons on the outside. So when a photon, this bundle of energy, hits the solar panel, it knocks an electron from one side of the panel to the other side. So you're moving electrons. When you're moving electrons, that's what electricity is. Electricity is just moving electrons. When you plug something into the wall, it's the movement of electrons. That's what electricity is. So if you're moving electrons from one side of the panel to the next, you're moving electrons, you're generating electricity. That's essentially how it works. It's complicated. That's the best I can give you. So you're generating electricity, in this case, which is a DC circuit, which we cannot use. That's what batteries typically provide. Everything in our house uses AC, alternating current. Again, not going to get too much into it. That's a little bit physics, but essentially direct current means just a constant flow of electrons. Alternating current is a back and forth flow. That's why there's two prongs on anything you plug in. Any case, so the solar panel, it creates DC current. That DC current is changed to AC current, and then that's what you can use inside your home. Whatever you don't use, typically, if you have solar panels on your house, whatever you don't use gets put back into what's called the electric grid. So if you're generating more electricity than you use, you're putting it back into the system. So your meter, instead of electricity flowing in, you have electricity flowing out. So your electric meter is spinning the other way. So the electric company pays you. So if you don't use all that, it's going back into the grid, it's got to go somewhere, then they're paying you. But again, the upfront cost, And when it's nighttime, you can't utilize this unless there's large-scale batteries that you have. If you don't have those, then the solar panel isn't working at night, so then you use the electricity from the grid. So whatever you put in, you're kind of taking back out, or more if the panels aren't enough to power your home. So you could potentially make money, maybe not. But there are different types of solar technologies that are used at the industrial scale to generate electricity. So using mirrors, one of those is a parabolic trough type. So kind of a circular trough-shaped mirror. The sun hits it. All of that solar energy is concentrated on these tubes in the center of the mirror to typically have some sort of liquid in them, water. Water heats up, turns to steam, spins a turbine, which spins a generator, which generates electricity. Sound familiar? So again, they're shaped, these mirrors are shaped in a way that when the sun hits it, all of that energy gets concentrated on this tube here, full of whatever liquid that turns to steam, which spins a turbine, which spins a generator. Same thing, but flat mirror called linear Fresnel types. They're flat mirrors, but they're all kind of angled differently and reflect back again to some sort of tube, maybe containing water. That water, the sunlight hits the mirrors, concentrated on those tubes. Those tubes heat up, water heats up, turns to steam, spins a turbine, spins a generator, generates electricity. Sound familiar? So again, so instead of a bunch of curved mirrors, they're all flat, but they're all angled differently, so they hit this kind of center tube. You also have something called a heliostat type. Same kind of process. Mirrors, the sunlight hits the mirrors. These mirrors can change angle depending on where the sun is in all of these types. In this case, it reflects the solar energy back to the tower. That there's material in there that heats up. That I believe in this case, though, you're heating up liquefied salt or salt water, and that salt water heats up and then that pipe goes through another tank of water, which heats up fresh water. That fresh water turns to steam, spins a turbine, turbine spins a generator, generates electricity. So again, here's one of those heliostat types. It's usually a large tower, and all these mirrors kind of reflecting back to that one central tower. Here's kind of a 360 heliostat. So the issue with these things is if birds fly through that beam, they're going to get cooked. And it takes a lot of land. But in this case, you're not using solar panels. It's just a bunch of mirrors. So you're cutting back on technology costs, but you do need a lot of land. So those are all ways to generate electricity. But we can also use them for other things. We can also use active solar to generate heat to, for instance, heat water. All right. So you can have, and some people, I knew people in Arizona that had this, instead of a hot water heater. Mine's in my garage, which is it's natural gas. It's natural gas. So essentially, there's a flame inside the hot water heater that heats up water. But some people in Arizona, around the country, around the world, and even here that I know, have solar water heaters on the roof. So essentially, what they're doing in a different fashion. So it's a kind of a large kind of panel on their roof, and in it, back and forth, are a bunch of the water pipes itself. As the sun hits the box that contains all the water pipes, the sun heats up the pipes, heats up the water in the pipes, which then gets stored, and you can use that as hot water. At nighttime, obviously you don't have this, so you might have it also hooked up to electricity or gas if you want to use hot water in the evening time. But this is another way that we're actively using solar energy. Here's another example of that. Again, all of these pipes probably made out of metal, or sometimes they're glass, which can have some issues. Oftentimes they're metal, right? The sun hits it, it heats up the pipes, heats up what's in the pipes, water, therefore you're getting hot water. So, what are some advantages and disadvantages of solar? No air, no water pollution. You're just using the sun. It's great. No CO2 emissions, no carbon dioxide whatsoever. Reduces the need for fossil fuels, power plants that burn those. It does save homeowners money in the long run, but that's if you put the money, that cost up front is too much for a lot of people. In the long run, you get that money back, but do you have that money to invest in it up front? That's the hard part. Again, they're expensive to manufacture and install, so these things are kind of pricey. When they do manufacture specifically photovoltaic cells, oftentimes there's a variety of toxic metals and other chemicals that are used to make the panels. And as of right now, there's really limited storage capacity, meaning for a solar panel to generate electricity, if we're using it in the daytime, that's great. And if we're not using it, it gets put into the grid. But at nighttime, we can't use the solar panel. It's not generating any electricity. So how do we store that? So some houses, and Tesla, the company Tesla, owned by Elon Musk, are really trying to develop batteries, storage batteries, so you can store that electricity. Instead of maybe putting it into the grid, you can store it in large batteries, so at nighttime you can still use that electricity you generated because it's being stored in large batteries. But the key is creating batteries that are cost efficient, size efficient. That's been a big issue. That's been a really big issue. So there is limited storage capacity, and as of now, it's somewhat expensive. It's getting better, though. It's getting better. So that's active solar. But there's something that all of us use every day as far as solar. We don't need any fancy technology. It's called passive solar. Do you know what that is? It's your window. I never have any lights on in my office, with the exception of a light I have right here just so you can see my face. When I'm in my office by myself, that's not on. I use passive solar. Just open up the window. The light from the sun is enough. I've been in my office for a number of years. I've turned on my lights a few times, maybe, and that's when I've worked at night. Like probably 5 times is how many times I've turned on the lights. I forget sometimes where the light switches are when I need them. I'm like, wait, where are they at again? You have this at your home, right? Passive solar. It's great. The way houses are constructed have this in mind, all right? And you can actually build houses in such a way to further have this in mind. So, for instance, the reason we have these overhangs on our house is for a number of reasons. One of them is in the summertime when the sun's kind of more directly overhead, it shades our windows from the sun. So it's not just beaming in. So we would have the heat outside plus the sun. Oh my gosh, it'd make it unbearable. But in the wintertime, when the sun's a little bit lower on the horizon, it's cooler outside, well, that sunlight we can actually utilize to our advantage. We can actually utilize that to our advantage and use it as light because it's not so hot outside, so we're not adding to that heat. There's also some heat-absorbing floors, especially tile. Tile, when it's shaded, it's cool. That's why there's a lot of tile in houses in Arizona. But in the wintertime, when the sun hits that, it heats it up. So you can have a naturally heated floor. You're not stepping on cold tile if the sun's hitting it. So we're utilizing passive solar. I was in the grocery store the other day. I looked up. Passive solar. There's a skylight. There it is. All right. It doesn't have to be fancy technology to utilize solar energy. Sometimes you can use your windows to your advantage. Passive solar. You're not actively doing anything to the sun to create electricity or to create a benefit. You're just opening a curtain, opening a skylight. Ah, there it is. All right, let's pause here. That was solar. When we come back, we'll talk about wind. I'll see you back here in just a second.